Welcome to another video, and the next probe in our mini series about the different hardware debuggers is the ESP-PROG. This is reasonably priced from $20 to $30 and is designed by Espressif to be used with the ESP32 boards initially, but it's actually based on the same FT2232 chipset that we saw in our previous video, so can be used with other boards as well. So there are two sets of breakouts on the ESP-PROG to suit standard 0.1 inch connectors as well as the 0.05 inch connectors, making it easy to connect using jumper leads, or if you wish, small ribbon cables for a more integrated design on your own board, for example. The ESP-PROG also has two jumpers for the power supply to each of the two interfaces available, and this allows you to switch between a 3V or 5V supply from that interface. For the ESP32, these should both be left at 3.3V, however you can use this with other boards as well, so if it is a 5V board you may need to change the jumpers. Also ensure, if you are powering your target from the probe, that you only connect one of the VCC lines between the probe and the ESP32. Remember, there are limitations on the number of concurrent breakpoints which can be set, and for this probe we believe the limit is a maximum of 6 breaks and 4 watches at the same time, but this is limited by the hardware in the toolchain as well. So for the ESP32, for example, it generally only allows 2 concurrent breakpoints. It can also be used to debug non-ESP32 boards, as it supports JTAG and SWD for debugging and programming. If these aren't pre-configured, a custom configuration can quickly get you up and running, and there's a link in the description as to how you can set this up. So using your ESP32 based project with this single piece of hardware, you can program and debug your board with simple option selections or a custom configuration. Connection diagrams are available for a variety of boards on our website, links below, with a few of them shown here for the ESP32. And if you are powering the board through its own USB connection, don't connect the power line between the ESP-PROG and your ESP32, as this would also supply power to the board, which might be a problem. So if you do have a problem with there not being enough power to your target ESP32, then you can connect it to the USB port as normal and then disconnect the VCC line between the probe and the board. Ensure you leave the ground line connected between the board and the programmer in all scenarios. So now you've got your board wired up, we can get this working in Visual Studio and with Visual Micro. So if you load your sketch in Visual Micro and select your board as normal, we can simply set up the debugging by selecting the debug hardware option and the ESP32-PROG option from the drop-down lists. If you want to use this as a programmer as well instead of the USB port, then you can select the option from the vMicro upload hardware programmer option, allowing the upload to happen through the JTAG or SWD interface instead of through the serial port. As with the FT2232, you can run your serial lines through the second port, meaning all connections from your board can run through the probe itself, as well as the power to your target. If you have connected the serial wiring through the probe, then you can select this COM port instead in Visual Micro, so you've got the serial link to your board available. So to allow the debugging software to locate and control the debug probe, we will need to alter the default driver installed in Windows for this device. Connect the probe to your machine through the USB and install the Zadig tool, link below. Once Zadig is loaded, you can simply click List All Devices from the Options menu and then select Interface 0 of your device from the drop-down. Then simply select the WinUSB driver for installation and then click Install. It can take a few minutes for this process to finish. Note, we don't need to change the driver on interface 1 as this is the Serial Passthrough port and the driver is fine as it is. Remember, if you do move which USB port of your PC the probe is connected to, you may need to reinstall the driver with Zadig. Now that's done, we can close Zadig down. To set a breakpoint in your sketch to stop at and amend any settings, you can make it a trace point as well, and there is a link available above, so you can be taken through how to use breakpoints and the general hardware debugging system, and this is applicable to all hardware debuggers in Visual Micro. You can also perform your build and upload as normal, but if you run debug and attach to process, you enter the code where it currently is on the chip, which is particularly useful if you want to jump into the project once something has gone wrong. Alternatively, you can run debug and start debugging, which will perform the build and upload and then attach the debugger at the start of the program, i.e. at the start of setup when it starts. If everything isn't working as expected at this point, then please see our hardware debugging troubleshooting video as shown in the top right, and this will guide you through resolving some common issues. Once you've had your debugging session start, you can inspect variables, move breakpoints, reconfigure the breaks and traces, and walk through your code line by line. Let us know in the comments if this was a useful video and if there's any other details or features we need to add to this series or this video that you need. Also, don't forget to check out the other videos on our channel and give us a like and subscribe to stay up to date with more videos as we release them.